Hello and welcome to the E-Mobility Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss, and in the coming episodes I'm delighted to provide insights on discussions I had with leading experts on the field of e-mobility at the e-mobility production days hosted by PEM of RWTH Aachen. What's the status of innovation and where are we headed? Let's find out. So, can you elaborate really quick? What are we looking at? Maybe talking about construction equipment.
Yes.
What are the key challenges there?
There's a big difference between the automotive sector and the construction equipment sector. In the automotive sector, the volumes are so high that it's possible to completely redesign a vehicle just for electric propulsion or e-drive system. If we look at the construction equipment industry, there's a huge mix of machines, and also the volumes per machine are sometimes very low. So it's not very beneficial to do a complete redesign of a machine that has been in the manufacturing process for in diesel and hydraulics for such a long time. So changing the machine to the battery or changing the battery to the machine. This is the question.
So to draw the analogy, in the car sector, we're now talking about the skateboard, right? We have the four wheels, and then we have this base plate on the bottom, where we basically put the battery and the whole drive unit, and then put the chassis on top. And now what we're talking about, construction equipment, the frame, everything is there, and we cannot really mess with it. Also from a functional point of view, right?
Yes.
Because construction equipment has its shape and it's all extremities, like cranes, etc., for a certain purpose. Yeah. Right. So tell us about how you address this challenge.
So I think there's a nice analogy we can see in how diesel engines or combustion engines are also used in the current industries. In the automotive industry, the volume is so high that you can see that most of the OEMs also make their own combustion engines. Mm-hmm. But in the construction industry, the volumes are not there, and the R&D capacity is not always there to do their own diesel, commonly diesel engine, and it's sourced from an outside supplier. So also there, you see that there's this difference, and that there's not always the machine is not always changed to the engine, but the engine is selected to fit the machine. Mm-hmm. Yeah? Mm-hmm. We cannot change the machine a lot, so in this fixed space envelope, normally we had the diesel engine in the tank, and in that space we need to put the battery. There we think the approach to get the longest running time, so the highest capacity in the machine, is to make a customized battery. If we work on standardized modules, we will see that it's not possible to completely fill all the space that is available because there's less flexibility because the building block is too big.
Mm-hmm. So you mean you cannot build small enough Lego bricks to really fill up the space elegantly?
If you use large modules.
Do it modularly, so that there you enter the customized approach. Interesting. How big is the range of your product portfolio then?
Yeah. Every customer gets his own battery, so the product portfolio is huge. Okay. And then the first thought in this is how can you manufacture this wide scale of batteries, and how can you do it cost competitively? That's the immediate
question I want to ask also from an entrepreneurial point of view, like how can this economically be sustainable? How can it operate the company in a way that it's not completely a novelty, like in the pilot production phase, that we have like everything is new always. Yeah. You don't want that in the company necessarily, right? On the production line.
No. So this is the challenge we had to overcome. This is the most important thing. And what we have been doing in the last years is having a design philosophy and improving this design philosophy to make sure that we are very flexible, but have it that it's easy to manufacture. So the quality is good, the pricing is good, the lead times are good, and this was the challenge to take into account.
So if you can talk about it, how do you solve that? Like where does the competence in your strategy lie? Having this high flexibility in the products you're offering, but maintaining a systematic structure in your company, in the daily operations. How would you describe the strategy that you're following there?
I think the underlying competence, there are two main things. One is creativity, and the other is really understanding the needs of the customer. It turns out that we tell our customers on the outside the battery always looks different and is made to customer specification on the outside. If we look on the inside to make it manufacturable and cost effective and on a high quality way, is the challenge that we are on the inside. For us, technically, it's almost all the same, all the batteries. So 90% of all the components and the design philosophies are the same. Normally, if we look in automotive, there's still a lot of work being done with battery modules. Usually there are 8 or 12 cells, and then these modules are put into a battery pack. For us, the step is a single cell. So this is our building block, and that gives us the flexibility. So that's just one part of the flexibility that we can do. We always do cell-to-pack configurations to make this high energy density. And if we look more on the control side, like battery management, we have a very scalable system that can range from 24 up to 1000 volts.
Oh wow!
So it's for us, we have a master-slave architecture.
Okay, so you scale through master-slave then?
Yeah.
Because I was wondering, okay, in the voltage range, is it also economically viable to offer the same management system then? We see commonly that we are most on cost-effective levels from 20 kilowatt hours and up, basically. This is more our benchmark. We do have customers that have smaller batteries from us. We see that the price per kilowatt hour is quite high for smaller batteries, but if there's a very specific need for a high level of customization, it could still be beneficial in some niche applications. Okay, gotcha.
So 20 kilowatt hours and up is where we feel comfortable.
If you would name one key innovation area where you see big progress being made in the non-road sector, what would it be?
Yeah, I think most progress is in the electro-hydraulics.
It's the electro-hydraulics still? Okay.
I think there's still a lot of efficiency to be won there, so that will really help to reduce power consumption or energy consumption, and that will increase runtime of the machine, and this is what everyone's looking for. We see some customers who start by just taking out the diesel engine and making an electric drive on the hydraulic pump, so keeping all hydraulics in place. It's a quick win, it's quite an easy conversion. They start off doing that and building some market share and proving that the market is there for their electric products, and then in the next generation they move into these things. Yeah.
Okay, and addressing your area of competence, now specifically on the battery side, what is the applicational area where you see the biggest movement in terms of non-road or also other, where you require this customer-specific implementation of battery packs?
In the last few years, most of our customers were in the relatively small machines, the lighter machines. So let's say under 20-ton machines, battery packs up to maybe
light, under 20 tons.
Relatively light. So battery packs are ranging, I think, up to 100 kilowatt hours, is it more or less? And now we see a push and more requests also for the bigger machines.
All right, so then thank you very much for the conversation. Looking forward to the next one, as I said, and enjoy the conference.
Yeah, thank you very much.